Okay, what we studied in the last class, we discussed this statement, right? So this equation, P of x1 to xn, which is equals to phi n, I equals to 0 to n, and then xi implies parent of xn. Right. So this equation we have discussed. So now we'll just construct. So then here we have seen how this network works, but we have not seen how to construct this network. Right. So how to construct this Bayesian network? So this Bayesian network we can construct using the representation of this joint distribution, and we can use this conditional independence relationship. Conditional independence relationship to write this equation. Okay, or to construct the Bayesian network. So, how we are going to do this? We are going to rewrite this equation 1 using the product rule, and we are getting the next joint distribution. So, how to rewrite this? P of x1 to xn is equal to xi minus 1 comma x1 xi minus 2 comma x1. So this will continue till we get x2 comma x1 into p of x1. So this we can simplify as pi of I equals to 1 to n p of x. ಏನು ಕೇಳಿಸ್ಕೊತಾ ಇಲ್ವಾ? P of xi plus xi minus 1 till x. Okay. So if we rewrite this equation, before this we had one more equation. So by using that equation, we have simplified this. We have got this equation. So now using product rule, and if we rewrite this equation, we will get the product as this one. X phi of I equals to 1 to n pt of probability of xi implies xi minus 1 to x1. So using this or comparing this first equation and second equation, so what we can say? So this rule we can call it as chain rule, where it holds the random variable. And if we compare the first equation and the second equation, we can define it as P of xi implies xi minus 1 till x bar equals to P of xi implies parent of xi. Okay. So we can compare. If we compare this equation 1 and equation 2, so this will be deleted and only this 2 will be there. Right. So now we can say that this P parent of xi is a subset or it belongs to this value. Right. So we can write it as parent of xi is a subset of xi minus 1 till x1. Okay. So ಏನು ಅದು So to the second equation, this equation will say that Bayesian network is a good correct representation of the domain of this domain, right? So when we can do this, only if the variables are independent of if the nodes should be independent of its previous nodes are predecessors. Okay, so only if these nodes are independent, we can define this domain and we can construct a Bayesian network. Right. So we have two methods which we have to follow in this constructing the Bayesian network. One is the node. So the another one is the links. So nodes will determine the set of random variables which are required to mention in that particular diagram graph, right? So this can be in any order, and if the order is changing, it will compact our construction or the network. So what about the links? For so we have written here, right? I equals to 1 to n. So for every I equals to 1 to n, we will be defining a link, right? So there should be a parent link. So for so consider we have this one. So for this there will be a parent link, right? So for every parent, for every node, there should be a parent link that will be defining all other domains, all other nodes, right? So this one we can write it as conditional probability table, that is RCP. So these links can be written in conditional probability table. So that we call it as. So what is the link here? The table P of xi implies parent of xi. Right. So we have an example. Consider Mary is calling. You remember that example? Mary calls and John calls. So we had an example, right? So where we had this burglar. Okay, so in this example, we were saying that Mary and John will call. So once they hear the alarm, so in some cases they may miss this alarm too, right? So in this case, for this the construction of domain, construction of Bayesian network, we have taken an example where Mary calls are directly influenced, are certainly influenced by the alarm. Okay, so Mary's call should be influenced by the alarm, and John calls can also be influenced by the alarm. Right. So, but Mary calling behavior, the calling behavior of Mary will directly influenced by the alarm. If there is no alarm, she won't call. Right. So the behavior of the Mary should be dependent on the alarm. So for this, and so here Mary calls is influenced by alarm, and John calls is also influenced by alarm, and the behavior of Mary and John will be dependent on alarm, but John cross is not directly influenced by the Mary. So this is our example. So for this example, how can we write this conditional independence relationship? So probability of Mary calls and John calls, comma, alarm, comma, burglary, and earthquake. So which is equal to probability of Mary calls, which is which is having a parent known as alarm. Only if alarm is ringing, so we will get to know whether this Mary will call or not, right? So that is why we will write it as all these are variables. Here we have said Mary calls and John calls is directly influenced by the alarm. So we have taken the next as alarm, and alarm will be only if there is a burglary or an earthquake. Right. So which is equals to, as per our statement, what we have to say, Mary calls certainly influenced by the alarm, and Mary calls behavior is influenced by only alarm. Right. So P of Mary calls, probability of Mary calls is dependent on alarm. Alarm is a parent node. Right. So next we have compactness and node ordering. Okay, so next we have this compactness and node ordering. So in this compactness, the Bayesian network will follow the local structure system, which we also call it as path system. So in this local structure system, it regardless of total number of components, each subcomponent will directly bounded with the other components. So what is this? So the correct node ordering of this subcomponents. So then consider we have this example, right? So instead of this, if we are deciding to add the load, so here we have burglary and earthquake as the first load. The thing is now we are changing it as Mary cars, John cars, and then Anara and burglary and last earthquake. If we are adding in this way, so if we change the modes as Mary cars, John cars, alarm, and burglary and earthquake. So how can we write the structure? So this kind of node. How can we write the node? So now instead of burglary, we are removing, we are adding the Mary call and then the John calls, and then we have another John. This is our burglary and earthquake. Right. So to add this, first if we are adding the Mary call, so Mary is having parents. So before in the previous diagram, Mary has an parent as Alala. Right. So now in this diagram, Mary calls has no parent. What about John? John is also not having a parent. But the thing is, how he will call? What if it is the alarm if since he is the parent now for the alarm, so we will be confusing with this telephone ringing and the alarm. So whether we will be directly calling the child, directly calling the person Karthik or not. So since there is a confusion in this person, we are taking Mary as the parent node. So now Mary is the parent for Alaras and Mary is the parent for Uta. Right. So next. So Alaras is the parent for earthquake and burglary. How is it related when we have burglary? Only if burglary happens, the alarm should ring. Right. So if alarm is ringing, the burglary and earthquake will not happen. So in this case, how can we write the mode? ಕೇಳಿಸ್ಕೊಳ್ಳಂದ್ರೆ ಕೇಳಿಸ್ಕೊಡ್ರಿ ಇಲ್ಲ ಸೈಲೆಂಟ್ ಆಗಿ ಕುತ್ಕೊಳ್ರಿ ಸುಮ್ಮನೆ ಕಿರ್ಸ್ತಾ ಇರ್ಬೇಕು. Okay. So when Mary calls and John calls, what we have done, there is an alarm which is the subcomponent, right? So the subcomponent. So in this case, what we are saying, so before that we had burglary as the parent node, and then burglary happened, the alarm was ringing. So in our case, when we change the node, Mary is calling, and once Mary is calling, the alarm should ring, right? So this method, this node ordering will not work. But the thing is, when we have added burglary at the end, so how can we write this conditional independence relationship? So probability of this burglary or earthquake is dependent on what? The alarm. So in here also the alarm is the parent node. Right. So and then if we add John cars and Mary cars, what will be the parent node? So how can we write the probability of John cars alarm? The alarm will be having the parent node as Mary cars, comma John cars. Right. So this now will be defined, and so the node ordering before we had links plus, and compared to this diagram and previous diagram, we have added two links extra and three conditional dependencies we can write it as extra. Right. So this will make you to get more nodes and more complicated network. Right. So because of this, we are saying that node structuring or node ordering should be in a discrete continuous method, so that we will get our work will be done. Okay. So next we have conditional independence relation in Bayesian network. So in this, the node will be independent, conditionally independent of its descendants to given its to the given pair. Right. So in case, so the example if we take the John calls it is independent of burglary and the earthquake, but the given parent is alarm. Right. So the second one is node is conditionally independent of all other nodes in the network. So for the second one, the example is burglary is independent of John calls and Mary calls, but the parent is alarm. So these are the two examples of two things. So first example is Mary calls and John calls are independent of burglary, but the parent is same alarm. Right. The second example is burglary and earthquake are conditionally independent on John calls, but the parent is the same alarm. Right. So both of the statement will state that the nodes are conditionally independent of its of. Okay. ಹಿಂಗೆ ಮಾಡ್ಕೊಂಡು ಹೋದ್ರೆ 2 ದಿವಸದಲ್ಲಿ ಥರ್ಡ್ ಮಾಡೆಲ್ ಮುಗ್ದೋಗುತ್ತೆ. ಸುಮ್ಮನೆ ಹೇಳ್ಕೊಂಡು ಹೋಗ್ತಾರೆ, ನೀವು ಕೇಳಿಸ್ಕೊಳ್ತೀರಾ, ಹಂಗೆ ಹೇಳ್ಕೊಂಡು ಹೊರಟೋಗೋದಾ? ಇನ್ನು 3 ಕಾನ್ಸೆಪ್ಟ್ ಮಾಡಿದ್ರೆ ಥರ್ಡ್ ಮಾಡೆಲ್ ಕಂಪ್ಲೀಟ್ ಆಗೋಗುತ್ತೆ. Afternoon irtara? Afternoon you are there for the class. Your Nandakumar sir is on leave today. Afternoon 1 hour ಅಷ್ಟೇ. ಆಮೇಲೆ ಎಲ್ಲಿ ಹೋಗ್ತೀರಾ? PWP. See, afternoon 2 hours project that Nandakumar sir have not given that class to anyone, and first hour is mine. If you are there, I will come. ಅಲ್ಲ ಬಂದು ಕೂತ್ಕೊಳ್ರಿ, ಫೋಟೋ ವಿತ್ ಲೊಕೇಶನ್ ತಗೊಂಡು ಹೋಗಿರಾ? ಓಕೆ. Do one thing, afternoon 12:30 you be here. I'll take one photo. 12:30 you be here. I will take photo. I will post it for the 5th hour. Okay. But afternoon, if they ask, I don't know what to do.